How's it going, guys? Max here. I know it's been quite a while since I posted the last video on the channel, so I'm back with something pretty exciting in particular. Join me today and we'll make an RC fixed-wing aircraft like none other. A remote-controlled Arduino-based 3-channel flying wing. And the bottom line question is, will it fly? Let's find out. So let's make this thing. Let's start out by making the hot wire foam cutting tool that we'll use to shape the plane. For the tool, I'm using 1/4 millimeter nichrome wire, which can be found in soldering irons or hair dryers. So we will basically take a rigid bow-shaped type of wooden frame and tightly wrap nichrome wire to each end. Let's solder and connect up electrical wire to each of the ends, and in the meantime give the tool a momentary push button. Hope you enjoyed my little performance there. So a thing I noticed with the tool is how it sags when it's heated up due to the wire expanding. Well, a little thing to counter that effect would be simply a retraction spring. So we'll hook it up here as a part of the wire that heats up. So as the hot wire heats up and stretches out, the retraction spring compresses, keeping the tension on the wire as you're cutting. So that makes this hot wire tool complete. Moving on, let's take a quick look at the materials and parts we'll need for this plane. So the core material to this wing will be this 1.5 inch thick styrofoam board that I have over here. And yes, this is just your everyday cheap styrofoam that's made up of these little balls that fall apart and crumb all over the place, making a big mess. Well, that'll be a mess no more with this styrofoam cutter that we just made back here. So let's hit it, shall we? So to achieve the desired size and shape of our Sweptback wing, we're going to follow this design over here. The wing will have a wingspan of about 80 centimeters. So to start with the slicing, let's cut this sheet of foam in half, dividing it into what will be 2 wing halves. Then we'll cut off the excess around what was marked. With our wing halves prepared, let's make the 2 airfoil shaped stencils, which will go on the sides of each half wing section and be the guidelines to help create that correct airfoil shape so that the plane can gain lift. We may also sand the edges a bit so that the hot wire smoothly glides over them. Aside from wood, a dense and smooth material such as acrylic may be used to make the stencils as well. So let's stick these 2 stencils onto the sides of one half wing section and add some toothpicks to the front and back so that you're guaranteed with an accurate leading and trailing edge. Setting the power supply to 9 volts, and yes, you may instead choose to use 9-volt batteries for this. Holding down on the hot wire tool's push button will slowly but surely make our way from the leading to the trailing edge, making sure the wire enters and exits the sides at the same time. These ones came out looking pretty rough. It's not as easy as you may think. It took me about a couple of attempts before I started getting smooth looking wing half sections. Now that we're starting to achieve much better results making these half wing sections, we can already see where this is heading. Using nails is an even better way of attaching on the wooden stencils onto the sides of these blocks of foam to cut out the half wing foam sections. This way the sides don't get damaged when pulling off the stencils. Now we will adjoin the 2 wing half sections with these 4mm wooden dowels. This solution will work great as the wing's reinforcement. I recommend having them as close as possible to the center of gravity of the final plane. The more we reinforce the plane, the better, as long as we're keeping the weight down. Let's also reinforce each end of the plane with some barbecue skewers. With the foam wing being all reinforced, we can start making the needed cutouts. Except we won't yet touch the area where the electronics will be sitting in. Out of the same piece of foam, we'll cut out each of the elevons, the only 2 control surfaces which the plane uses to pitch and steer with. These are technically the combination of the ailerons and elevons seen on a typical plane. Now we'll start by laminating them and then the rest of the wing. Sellotape seems to do the job pretty well. It's thin, lightweight, and even sticks to the foam nicely. My best advice for laminating a wing with tape is to start from the trailing edge and all the way up to the leading edge. We'll stick the elevons to the wing body with a strip of tape from the top and then a few smaller pieces from below. Since sellotape has heat shrinking properties, you can actually use a hair dryer to smoothen out any rough areas where the lamination went a little wrong. While we're still taping, let's add some decorative strips of Kapton tape. Right, so the flying foam wing itself is now finished. It's been reinforced with wooden sticks, laminated with tape. It's turned out to be pretty sturdy, and it already looks quite sporty. Yeah, so now on with the electronics, starting by making the receiver unit. Before we mount any modules or components onto the PCB, we must first add in some female pin headers so that the modules can easily be replaced if needed. This board will feature an Arduino Nano microcontroller board and NRF24 radio frequency transceiver module. To give the radio frequency module a stable supply of power, we'll give it this 3.3 volt regulator down here. To smoothen out any ripples and power to the radio transceiver, we'll give the inputs and outputs of the regulator some filtering capacitors. With all being mounted onto the perforated board, we can start with the wiring. For the best power filtering to the module, it's actually better to solder them as close to the pins as possible. To keep the weight down, we can also trim off excess perforated board. The receiver has ended up weighing 16 grams. For the servo motors to connect to the receiver, we'll solder on some extended pin headers. For the battery of the plane, we'll form 4 of these lithium polymer cells into one battery pack. 2 pairs of cells in series and then put together in parallel will equate to a 7.4 volt 500 milliamp hour LiPo battery pack. This battery pack set of connectors will be shortened down to something a lot more discreet. Let's hook things up with the current system to see that the circuit is working. The Arduino codes for the transmitter and receiver can be found linked in the description. Here we'll measure and cut out areas on the plane where the servo motors will be embedded into. Let's be sure to embed them into the thicker part of the wing, closer to the leading edge. And the servo wires going all the way up to the receiver can be embedded in the wing too. Now let's make a mounting plate for the brushed 180 motor. What keeps the motor mount more firmly seated into the plane is that it's also super glued to one of the reinforcement beams. Why don't we also give the battery a sturdy wooden floor and a Velcro strap to keep it down tight. To secure the receiver well into the plane, we can use a combination of different techniques, a little bit of hot glue from the sides, some toothpicks, and it'll hold in tight. Just never glue a component directly into the styrofoam. The ESC or electronic speed controller also needs a spot. Let's glue it to the side of the receiver, along with its on-off switch on the other side. Since the circuit is powered by the battery through the ESC, this on-off switch toggles the whole circuit on and off. Checking the wing's center of gravity, it seems fairly balanced in both ways. Moving on to the control surfaces of the plane, I had prepared these little wooden lever arms which will be inserted into the elevons. The servo motors will be linked to the elevons through a section of wire. To counter these wires from bending around, let's stick in these zip ties for stabilization. For the brushed motor, I got this propeller from a cheap quadcopter. We'll modify it a little, giving it an adapter to fit nicely onto the motor shaft. With the prop on, let's hook the battery up and give it a little spin. Alright folks, so now I'm out in the nature about to test this Arduino-based flying wing. So let's see if it really can fly. At this point, I'm almost convinced the powertrain just isn't enough for this type of plane, and it clearly has a lack of thrust with this cheap drone propeller. But I got another thing up my sleeve, so I ordered in these 5-inch plane propellers, which are actually pretty rigid, unlike the drone propellers which would flex out at high RPM. With a new plane propeller that's got the right shape, I have no doubt it'll at least give a bit more thrust. But whether it's enough thrust for the plane to produce lift, that's another question. Okay, I admit it, the plane for sure is too heavy with this brushed motor. So brushless it is. I ended up ordering in this tiny 7000 kV Max brushless mini quad motor, purchased along with a 30 amp 2S and 3S brushless ESC. This motor, with a no load RPM of up to 60,000, this thing will rip. We'll also stick to the same propeller as before. So hooking up the rest of the circuit to this new brushless system, let's just check to see that everything will work. Without wasting any more time, let's get right into swapping the brushed motor for the brushless one. To get the little guy mounted, we're first going to need to make a little mounting plate. Reducing weight and saving some wire, let's trim down this ESC pretty much to a bare unit. Every time the battery gets plugged into the circuit, the ESC will need calibrating before each flight. It's as easy as raising the joystick and then lowering it. You could say it is now primed. Now for the mounting of the propeller. Using a flat-headed screwdriver, we'll simply tap in some grooves so that there's space for the screws to go in through. Instead of tapping, melting could even be a better way to achieve those grooves in the plastic. With these few adjustments made, the plane is certainly coming along. Going from 190 grams with the brush setup, the plane already weighs 18 grams less. So why wait? Let's test her out. It took a number of consecutive failed attempts of me trying to get it into the air. It would simply smack down into the ground, but as I started getting the hang of launching it, it really took off. Those flight test results seemed pretty promising, although I realized there could be a few more things and adjustments that may need to be done, such as giving the plane's electronics a form of protection, a cockpit, also known as a micro fuselage. Let's make the fuselage from some 5mm foam core or poster board foam. The Flying Wings blueprints are linked in the description. With the help of some toothpicks, let's make a hinging and a locking piece for the fuselage lid. Let's also give this flying wing some wingtip fins. These fins greatly help out with the stability of the plane, blocking out that vortex effect that gets created from coming in over the wing, destabilizing the aircraft. Wingtip fins are not mandatory for the plane, but they help. After adding some pretty cool decal stickers onto the fuselage, we can now laminate it as well. An efficient way of finding the center of gravity or CG of a flying wing is to set the CG back 25% of the area of the whole wing from the leading edge. Or for this plane with a wingspan of 80 centimeters, the CG is just set forward 8 centimeters from the motor. So it's important we check the center of gravity as we're building the plane. And remember, it's always better to have a plane that is a little too nose heavy rather than too tail heavy. With the weight of the wingtip fins and the fuselage, the plane only ended up weighing a little more than 10 grams heavier. I ended up removing this spring that kept the throttle joystick returning to the center, so now the vicious plane motor won't start up all of a sudden, slicing up the pilot without his input. Now the joystick will stay down at 0 throttle without holding on to it. By the way, you may check out my previous video where I showed how to make the transmitter. Since each joystick movement correlates to a specific servo channel, we would have to make the joystick movements diagonal for pitch and roll. Steering in mid-flight with roll should be done very incrementally as the plane can get affected with the slightest movement of the joystick.
Hey guys, so now I'm out here in this big wide open field with the Arduino-based fixed wing aircraft. So this is her maiden flight. Let's see how she goes. Alright, it started well, but kind of veered off to the side and crashed. Not a single scuff. She survived that. Let's keep rocking.
And if you're experiencing the slightest breeze, it's always best to launch the aircraft upwind and then go on from there. And if you feel that your aircraft is still a little nose or tail heavy, then be sure to leave enough room in the fuselage to adjust the battery back or forth.
So as I was flying, it went straight down, nosedive from high up, and one of the flaps broke off, so then I just ripped the other one off for balance, and now let's see how it flies without them.
For those of you wondering, the plane has an operating range of over 100 meters, and with a flight time of roughly 10 minutes. Maybe not as stable without the fins, but still made for some fun flights.
Okay guys, so for my first model RC plane, I think I did good. Though I would have liked to show you even longer flights of the flying wing in action. So with the little experience I have of flying these planes, these are the best shots I got so far of it flying. Later on in time, you may even get to see longer flights of this cool flying wing. Also, any diagrams or blueprints for this plane can be found linked in the description box below this video. So if you enjoyed watching, as per usual, kindly toss me a thumbs up, share, drop a comment, and subscribe if you're new to the channel. Stay tuned for the next one. Peace!